In this video, I'm going to show you 3 ways of backtracking. Now, we've been backtracking all year, so you should be pretty confident. And if you look at this first question, it's pretty straightforward. It won't take you too many steps, but how you approach the problem is what I want to talk about. So the first way is by rewriting. So if I was going to rewrite and solve this equation, what I would do first is I'd go ahead and distribute this 4 through the parentheses. So if I do that, I would have 4x, and then 4 times 3 is 12 equals 20. And now I just rewrote this, and then I would just backtrack from there. So I would subtract 12 on both sides because you get rid of adding and subtracting before multiplying and dividing. And then I would just divide by 4 because that's the opposite of multiplying, and I would just get 2. Now, undoing is basically another way of saying backtracking. And what you would do differently this time is instead of rewriting it, you would just simply backtrack. So you would get rid of adding, subtracting, then multiplying, dividing, then powers, and grouping symbols. So I would have to get rid of this 4 first because the adding is inside the grouping symbol. So I would just divide both sides by 4 first. That would cross this out, and I would have x plus 3. And 20 divided by 4 is 5. So if I subtract 3 on both sides, you can see I get the same answer of x equals 2. And that's, again, by backtracking where this one was rewriting. The third way is called looking inside. I like to call it cover up. It's usually when you have a grouping symbol, such as a parentheses, a bracket, a radical sign, absolute value, something like that. So if I just take my finger right now and I cover this up, 4, and it's right next to a parentheses, so 4 times something has to be 20. So think about that mental math, it has to be 5. So whatever I'm covering up has to equal 5. So when I uncover it, well, x plus 3 has to be 5, so that means x has to be 2. And again, sometimes that's working on your mental math skills, but sometimes you can be able to do that by just covering up the grouping symbol and finding out what the missing value is. Now, some of these have a couple more categories in them, like rewriting. There's a fraction buster video, which I'll be talking about next. But another way is, if you remember earlier this school year, I gave you some things where we had some exponents. So this would be like 81 to the power of 2x equals 1/9 to the power of x plus 1. And this would be something that you would probably want to rewrite just to make sure that the bases are the same, because right now you can't solve this until the bases are the same number. So what I'm going to do is I'm going to change 81 to 9 to the second power, because 9 times 9 is 81, and then the power that's already there stays there. And then if I change 1/9, that's the same thing as saying 9 to the negative 1, and I'm going to put the power that's already there. And again, by doing this is by rewriting, I went from 81 and 1/9, now they both have the same base, 9. So if I was going to solve this, I would just multiply the exponents. So 2 times 2x is 4x, and then equals negative 1 times x is negative x, and negative 1 times 1 is negative 1. So once you multiply those out, you can make these equal each other, because if they have the same base, you're just basically going to solve for x by backtracking here. So I'm going to add x to both sides to get the x on one side. So then I have 5x equals negative 1. So if I divide by 5, my answer to make this one true would be x equals negative 1/5. And again, it follows the idea of rewriting it before you solve it. Another example of rewriting is sometimes like we just finished a quadratic unit. So if I had x squared plus 1.5x minus 2.5 equals 0. And maybe it's like I'm trying to find the x-intercepts or the roots. So sometimes it's easy to get rid of all the decimals. You might just want to multiply everything on both sides of the equal sign by 2. When I do that, I'd get 2x squared plus 3x minus 5 equals 0, because 2 times 0 is 0. And by doing that, I make it easier to work with, because now I don't have any more decimals, I have just integers to work with. And if I look at this carefully enough, it looks like I can go ahead and factor this into two binomials. So if I have 2x and x, and if I put the 1 here and the 5 here, if I do FOIL, 2x times x is 2x squared, 5x minus 2x is 3x, and 5 times negative 1 is negative 5. And then I can easily solve this. So my answers are going to be 1, and the other answer is going to be negative 2.5. So again, the power of rewriting is really beneficial, and it can help save you a lot of time on things like this. Some other examples of looking inside, just to finish up with this, would be something where, again, let's say I had the absolute value of 2x plus 5 equals 11. Again, if I cover this up, when I do the absolute value, it has to equal 11 or negative 11 to equal 11 after I do the absolute value. So if I have a plus 5 and I want to make this into 11, this has to be 6. So that means one of my answers has to be 3. And then it also could be negative 11. So if I have a plus 5, this means this has to equal negative 16. So that means the other answer has to be negative 8, because negative 8 times 2 is negative 16 plus 5 is negative 11. And when I do the absolute value, I get 11. So again, using cover-up. Again, it's usually used, again, with grouping symbols. So if I do a radical square root here, and I do, let's say, 4x plus 20 equals 10. Well, if I think about it, if I square root whatever's inside here, so if I cover this up, the square root of 100 is 10. So I know whatever on the inside has to equal 100. And then if I add 20 to that, that means this has to equal 80. So then that means that x has to be 20, because 20 times 4 is 80, plus 20 is 100, and when I square root that I get 10. So again, just using the different techniques may help you as far as backtracking goes.